How does an object respond when a force is applied to it? What factors are important to know so we can predict the object's response? In this experiment, you'll find out for yourself. This is Newton's second law. Aeronautical engineers must know if a plane will fly while it's still in the design stage. How can they be confident about the performance of a complex machine that hasn't even been built? They use Newton's second law. In any experiment, it is important to understand the variables and to control them. We're interested in the motion of this cart, so we need to measure its mass, and we're going to keep that constant. The cart's mass is 0.36 kilograms. That includes a wireless force acceleration sensor that is attached to it. The force acceleration sensor will be used to measure the force applied to the cart and the resulting acceleration. We want to make sure the applied force is constant for each trial. To accomplish this, we've attached a string to the hook on the force sensor and passed it over a pulley on the end of the track. We have a weight on the other end of the string that will produce a tension in the string. After we release the cart, this tension will remain constant and cause the cart to accelerate down the track. The track level has been adjusted so that the tension is the only force that's causing the acceleration. We'll change the weight on the end of the string so that there's a different tension force acting on the cart for each trial. We've configured the SparkView software to display a graph of force versus time and acceleration versus time. There's a 20-gram mass on the 5-gram hanger tied to the end of the string for the first trial. After we make sure the weight isn't swinging and the string is over the pulley, we can start recording data and then release the cart. We can tell from the force graph when the cart was released because the tension force drops a little, then stays fairly constant. We want to select the part where the cart was accelerating and get the average or mean force value. We'll enter that in the data table for trial 1. We'll do the same for the acceleration graph, and then we can add 20 more grams to the hanger and repeat 5 more times. So here we go. So I just select that part where it was moving and then get the mean value. And so you can see it here on the screen. And so you'll be doing that yourself. And then for the acceleration, I want to make sure I do that for the same time period. And select the mean value. And then we can get that there. So one thing you might have noticed is the values are negative. And so the way we've attached the force acceleration sensor, the positive direction is opposite to the direction the cart is going. But that's not really a problem. You can just take the magnitude of the two values. You can make them both negative. They are both in the same direction. And so that's not really a problem. So it's trial 2. Now, as we add more and more, you might guess the acceleration is going to increase. And so we have to be pretty careful to keep the cart from flying off the track. So that's trial 3. Four. It's really going to get moving here. And so ideally, you would collect the mean value for each trial as you go, so you can keep an eye on things, but you're going to be doing all those yourself once you have all the data. Got it. And just one more. There, now we have all our data. It'll be your job to find the mean of the force and acceleration for all 6 trials. You can make the trials appear and disappear by clicking in their box here on the side. I like to just have one at a time. And you might notice a little vibration in some of the later runs when we had a pretty big acceleration, but that will be fine. The data will work well. After you get those acceleration and force values, you'll make a graph according to the instructions in the lab. Using your graph, you'll discover the relationship between the mass of the cart, the force applied to the cart, and the resulting acceleration. That relationship will help you answer the remaining questions in the lab, and who knows, maybe help you design a plane or two in the future.